Okay, in this video, we're going to learn about topic annuity. So note that this is the last topic under chapter 2. Okay, before this, you already learned about compound interest. Okay, the second type of interest. First, we have simple interest, and second one, we have compound interest. So what's the difference between simple interest and compound interest is? Simple interest, the calculation of interest is always based on original principle. However, in compound interest, the principle is always changes from year to year. Okay. So in topic annuity, we still use concept compound interest. Okay. So annuity, so you need to remember again concept of compound interest. In promissory note and bank discount, we use concept simple interest. Okay, but annuity, we will apply concept compound interest. So you still need to know what is nominal rate, annual nominal rate, which is value K, interest rate for each interest period, which is value I, frequency, conversion, and the interest period. Interest period, for example, compounded annually, compounded semi-annually, compounded quarterly, and so forth. Okay, so we still use concept compound interest. Okay, now let's look at what is meant by annuity. What is the concept of annuity? So annuity is a series of periodic payments or deposits usually made in equal amount at equal intervals of time. Okay, so what is meant by equal amount at equal intervals of time? Okay, examples here. Example of annuity are monthly rental payments, insurance policy, housing loan, and annual dividends. Okay, let's look at example monthly rental payments. Okay, example, you have a business, okay, where you rent a building. So every month, for example, you need to pay RM1,000 ringgit, okay, every month. So deposit in equal amount. Equal amount means that this 1,000 ringgit, equal intervals of time means that every month you pay it by monthly. For example, this one you need to pay it for 15 years, for example. Okay, so that is concept of annuity. You pay 1,000 ringgit every month. Okay, or maybe example here, housing loan. Let's say every month as well. Let's say now based on monthly basis, every monthly basis. Okay, every month you pay, for example, 1,500 ringgit. Every month pay 1,500 ringgit based on monthly basis. Equal amount, for example, January you pay 1,500 ringgit, February also you pay 1,500 ringgit, and so forth. Okay, at equal intervals of time. So this equal intervals of time, it can be monthly, okay, either monthly, or it also can be quarterly, or it also can be yearly or annually, or it also can be semi-annually. Okay, depends on the period. Example, if quarterly, every 3 months, for example, you pay 500 ringgit for a rental, for example. Okay, so every quarter or every 3 months, you pay 500. Let's say January to March, you pay 500. April to June, you pay another 500. Okay, and so forth. So that is concept annuity. So payment or computation of an annuity is computed by compound interest method. As I said before, annuity, we still use compound interest method. There are several classifications of annuity, which are annuity certain, annuity due, general annuity, and perpetuity. So for MAT112 and 402, we just cover the first one only, annuity certain. Okay. Okay, now let's look at some important terminologies under topic annuity. Okay, first we have payment interval. So what is payment interval? This is the period of time. So look at here, period of time. Keyword here is time. between consecutive payments means that either it is based on monthly basis, quarterly, yearly or annually or semi-annually, and another interest period. Okay? Okay, interest period, this is the length of time during which interest is calculated. So recall topic compound interest, interest period. If, for example, if quarterly, the interest period will be 3 months. Okay, example, quarterly, the interest period will be 3 months. If semi-annually, the interest period will be 6 months. If yearly or annually will be, we wait for 12 months. Okay, so that is interest period. The length of time during which interest is calculated. Okay, term of annuity. Term of annuity, this is the period of time from the start of the first payment to the end of the last payment interval, to the end. Okay, for example, let's say you made a loan to buy a car for 9 years. So term of annuity, T equal to 9. Okay, so that is term of annuity. Okay, next, annuity certain. This one, number 1 just now. Okay, what is annuity certain? This is a type of annuity for which payments are certain. Certain means that you know that, for example, every month you need to pay 500 ringgit to be made for a fixed period of time. Okay, example, you know that, okay, for 10 years, you need to pay for 500 ringgit every month, example. Okay, so that is meant by annuity certain. Payments are certain to be made for a fixed period of time. Okay, now let's look at ordinary annuity certain. What is ordinary annuity certain? So, an ordinary annuity certain is an annuity certain for which payments are made at the end of each payment period. At the end of each payment period. Example, if your payment is based on monthly basis, okay, so the payment will be made at the end of month. Okay, so that is mean ordinary annuity certain. If let's say your payment is based on quarterly basis, for example, start with January, quarterly every 3 months, right? So January, February, March. So what is ordinary annuity certain just now? Payments are made at the end of each payment period. So it means that January, February, you will make payment during March. Okay. For example here, if payment periods are in terms of months, then the payments are made at the end of each month. So if payment is 200 ringgit monthly, then the interest must be at 5% compounded monthly. Means that if here you pay by monthly basis, every month you pay 200 ringgit, then interest also must be compounded monthly. Means that every month we will calculate the interest. Okay, so that is ordinary annuity certain. So it cannot, let's say you pay monthly, but interest compounded quarterly. Okay, so this is not ordinary annuity certain. Okay, so if ordinary annuity certain, if you pay it by quarterly, interest also must be compounded quarterly. If you pay it annually, the interest also must be compounded annually. Okay, remember, if quarterly, the interest cannot be compounded monthly. Okay, so if you pay quarterly, the interest also must be compounded quarterly. So that is ordinary annuity certain. Okay, amount of annuity. This is the total worth of all annuity payments. Okay, at the end of the term of annuity. So which is, if in previous topic, this is actually value S. Okay. Present value of annuity. So this is the value of all annuity payments at the beginning of the term of annuity. So present value is actually value principal. So if based on previous topic, simple interest, compound interest, and promissory note, so present value, we use symbol P, right? Okay, the same concept, but in topic annuity, present value, we use symbol capital A. Okay, but the concept still the same. Okay, now let's look at future value of ordinary annuities. So future value here, we want to find value S. Okay, future value or accumulated value of an ordinary annuity certain is the sum of all the future values of the periodic payments. Periodic payments means that, for example, as I explained before, every month we pay 1,000 ringgit. Okay, every month we pay 1,000 ringgit. That is periodic payment. So the future value of an ordinary annuity certain is given by, okay, now let's look at this formula. So if you look at this formula, it is very familiar with previous topic, which is compound interest, where we still have value I and value N. Okay, recall what is I? Interest rate per interest period. So how we calculate I? K over M. Okay, interest rate per interest period. For example, if the payment based on quarterly basis, so quarterly basis frequency of conversion M equal to 4. So means that the period or interest period is 3 months. So every 3 months, how many percent? Okay, so that is interest rate per interest period, value I, K over M. Okay, N still the same, term of investment or term of borrowing period, which is number of interest period. Okay, so N equals to M times T. Let's say you need to pay based on quarterly basis for 2 years. So every year or within 1 year, we calculate interest 4 times. If your investment period or borrowing period is 2 years, then within 2 years, how many times we calculate interest? N equals to 4 times 2, which is equal to 8. Okay, so that is value N, term of investment or number of interest period. If you look at here, you have one new value, which is value R. So what is R? R is periodic payment. What is periodic payments? Example, before this, as I explained, every month, let's say you need to pay 1,000 ringgit for a rental. So that is value R. Every month you pay 1,000 ringgit. So this is the annuity. Okay, periodic payments. If let's say here you need to pay by quarterly basis, so every quarter how much you pay? For example here, every quarter you pay 500 ringgit. So R here equal to 500 ringgit. Okay, so that is periodic payment. So in annuity, as I said, we still use concept compound interest. The new thing for you here is value R, which is periodic payment. In compound interest, we don't have value R. Okay. Now, I want to give you some tips on how to distinguish between question compound interest and annuity. So, in annuity, we have value R. So, here are some keywords for value R. Okay. Okay, let's say every month she pays 1,000 ringgit every month. So this is to denote value R. Or maybe each quarter she pays each quarter. Or maybe it can be the monthly payment or the quarterly payment. So that is to represent value R. Okay. So every month, each month she pays 200 ringgit, for example. So this is keyword to indicate for value R. Okay. But in topic compound interest, there is no information mentioned about value R, which is the periodic payments. So in annuity, how we calculate future value or value S? So S equal to R multiplied by 1 plus I power of n minus 1 divided by I. So I equal to K over M and N equals to M times T. Okay, now let's look at how to calculate interest based on future value of annuity. Okay, before this, in topic compound interest and simple interest, how we calculate interest? I equal to S minus P, right? Okay, but in topic annuity, how to calculate interest depends whether it is based on future value or it is based on present value. Okay, so if let's say you have info about future value, value S, so how to calculate the interest? So I is given by S minus N times R. Okay, so S is the future value and NR is how many times we pay the periodic payment. So remember when we calculate value I cannot be negative. Okay, now let's look at example here. Okay, look at number 1. Deposits of 250 ringgit each. Okay, this is the keyword for periodic payment. 250 ringgit each are made into an account at the end of every month. So just now at the ordinary annuity settle means that the payment is made at the end of payment period. Okay. So end of every month at an interest rate of 4% compounded monthly. Find the amount at the end of 2.5 years and the interest. Okay, so we want to find value S, amount at the end of certain years means that value as future value, and amount of interest. Okay, look at here, ordinary annuity certain just now. If we pay it by monthly basis, the interest also must be compounded based on monthly basis. Okay, you cannot pay every month, but the interest is compounded quarterly. That is not ordinary annuity certain. So if we pay every month, the interest also must be compounded every month. Okay, now as usual, let's extract the info given. So 250 ringgit each. So that is the periodic payment, which is value R. At an interest rate of 4% compounded monthly. So annual nominal rate 4%, 0.04. Compounded monthly frequency of conversion M equal to 12. Find the amount at the end of 2.5 years. So T equals to 2.5 years. 2.5 years also equivalent to 2.5 years. Okay. Okay, now look at here. This is to indicate topic annuity. Okay, so use formula annuity. Formula annuity, we have value R. But if formula compound interest, S equal to P1 plus I power of N. So in this formula, there is no value R. Okay, so that's how to differentiate topic compound interest and topic annuity. Again, topic annuity, we have annuity value here. This is the keyword. Okay, so how to calculate future value? S equal to R multiplied by 1 plus I power of N minus 1 divided by I. Okay, as usual, you calculate value I separately first. So I equal to K over M. So 4% divided by 12 is 0.003, right? 4%. So this is rate for 1 year. So if the payment is compounded monthly, means that every month you need to pay, or every month the interest is being calculated, so divided by 12. So we get 0.003. Okay, so this is in standard form. So how to change in its actual value? You press Shift ENG, you press twice. Again Shift ENG until you get power of 0 here. So this is the actual value. So 1 year is 4%. Every month, since compounded monthly, every month the rate is 0.00333%. Okay, so since this is a long decimal point, just round off your answer up to 4 decimal points. So now we can write it equal to 0.0033. So n equal to, so 1 year we compute or we make payment for 12 times because every month. So if 2.5 years, how many times? Will be 12 multiplied by 2.5. So 12 multiplied 2.5 is 30. Okay, now substitute the value. R 250 multiplied by 1 plus I. So I just now 0.0033 power of n. So n 30 minus 1 divided by I 0.0033. Okay, calculate value in bracket first. So I do this part first. 1 plus 0.0033 is 1.0033. So you can directly press your calculator to save time. Power 30, so power 30. And then minus 1. So you can just directly press equal. And then minus 1. And then again press equal. Okay, now divide by value I. Divided by 0.0033 equal. So this one is value inside bracket here. Okay. And then multiply by 250. So I show this way because some of you do not know how to press calculator directly. Okay, so you can calculate one by one like I showed before. So now S equal to 7870.18. So S equal to RM 7878, what is now 7870.18. That is the amount at the end of 2.5 years. Okay, now interest. So just now how to calculate interest. Okay, now we base on future value. If interest based on future value for annuity, R equal to S minus NR. So S just now 7870.18 minus, so I continue here, minus. So how many times we pay R just now? 250 just now? 30 times. Okay, so minus 30 multiplied by 250. So interest will be 7870.18 minus 30 multiplied by 250. So this is future value at the end of 2.5 years. So every month you pay 250. For how many times? 30 times. So interest will be future value minus what you already paid. Okay, or how many times you pay the periodic payments. So interest is 370 ringgit 80 cents. Okay, that is concept annuity. So annuity we have value R here. Okay, now let's look at number 2. RM 400 ringgit is invested at the end of each 6 months period for 15 years in an account that pays 14% compounded semi-annually. 400 ringgit in each 6 months, 14% compounded semi-annually for 15 years. Find the amount in the account at the end of 15 years and the interest earned. Amount at the end of 15 years means that future value, which is value S. Okay. So now how do we know this is annuity question? Okay, look at here. Okay, the keyword here. Each 6 months. We invest 400 ringgit in every 6 months, each 6 months. So word each here to represent annuity of 400 ringgit. Okay, now as usual, let's track the information given. So R, the periodic payment here is 400 ringgit. T equal to 15 years. What else? 14% compounded semi-annually, nominal rate 0.14. Semi-annually means that every 6 months. Okay, so if you pay every 6 months, then the interest must be compounded semi-annually. Semi-annually, the interest period will be 6 months. Okay, so M equal to 2. Within 1 year, we calculate interest 2 times since the interest period is 6 months. Okay, find the amount in the account at the end of 15 years and the interest and value S and value I. Okay, as usual, we calculate value I first, interest rate per interest period. Means that every 6 months, how many percent? Okay, 1 year, 14%. So if 6 months, how many percent? So I equal to K over M, 14% divided by 2. So here we get 7%. Okay, and 1 year, we calculate interest 2 times. So if 15 years, 15 times 2 or 2 times 15, which is 30. Okay, how to calculate future value? So formula S for annuity is S equal to R multiplied by 1 plus I power of N minus 1 divided by I. Okay, then substitute the value. So R 400 ringgit, amount that we pay every 6 months. 1 plus I 0.07 power of 30 minus 1 divided by I 0.07. So if every 6 months we pay 400 ringgit with interest of 14%, so at the end of 15 years, how much actually we pay for the annuity? So calculate here. Okay, I calculate value in bracket first. So 1.07 multiplied by 30 minus 1 divided by 0.07. Okay, then multiply by 400. So 37,784 ringgit 31 cents. Let's recheck 37,784.31. Okay, so if you pay every 6 months for 400 ringgit for 15 years with this rate, so at the end of 15 years, this is the total amount or total annuity that you actually paid. Okay, so how about the interest? So now we are based on future value. So if based on future value, I equal to S minus NR. NR is how many times we actually pay the annuity. So at the end of 15 years, we already paid 37,784 ringgit 31 cents. Minus N, we paid for 30 times R, 400 ringgit. Instead of 400 ringgit, you already paid for 30 times. So interest here equal to interest is 25,784 ringgit 31 cents. Okay, now number 3. Let's look at number 3. 150 ringgit was invested every month. Every month. So this one to indicate the annuity every month. Okay, so this is the keyword. In an account that pays 8.4% compounded monthly. So if you invest every month, the interest also must be compounded every month or monthly for 2 years. After 2 years, no more deposit was made. No more deposit was made means that no more value R. You did not pay 150 anymore. Okay, find the amount in the account at the end of 5 years. Amount in the account at the end of 5 years referring to future value, which is value S. Okay, for this type of question, since there is no more deposit after 2 years, means that no more value R, which is 150 here. So better you extract the info into timeline. So easy for you to understand. Okay. Okay, let's say I put in this timeline. So total period is 5 years. Okay. We invest every month 150 ringgit. So R equal to 150 ringgit. After 2 years, no more deposit was made. Okay, let's say if total is 5 years, after 2 years, here T equal to 2. So here balance another 3 years. So balance another 3 years here, no more deposit. 3 years. Here, no more R. Okay, so means that there is no 150 ringgit for the rest of the period. Means that another 3 years. First 2 years, every month we invest 150 ringgit. Okay, the interest rate is 8.4%, means that from beginning to end of year 5, interest rate still compounded monthly 0.084, 8.4% compounded monthly, so M equal to 12. Okay, calculate I. Let's say I calculate here, I equal to K over M, 0.084 divided by 12. So 8.4% divided by 12 is 0.007. Okay, if you get this standard form, again press shift ENG twice until you get power of 0. Okay, in this case, first 2 years only we have annuity, but another 3 years no more annuity. Okay, we need to calculate future value at the end of year 2 first. Okay, why? Because after 2 years no more annuity. Okay, I put value at the end of 2 years as S1. Okay, let's say I put here S1. What is S1? Future value of annuity that you put 150 every month. Okay, future value of annuity means that 150 ringgit that we pay every month at the end of year 2. Okay, so if annuity future value S equal to R 1 plus I power of N minus 1 divided by I. So R 150 ringgit 1 plus I. So along 5 years, the rate still the same. Okay. So I equal to 0.007. Okay. And how about N? Okay, look at. Now we calculate at the end of year 2. So if at the end of year 2, N equal to what? Okay. So M equal to 12 every month. Okay. Compounded monthly. So M equal to 12. So M still the same. Okay, n equals to m times t. So now until year 2 only. So m 12 times t 2. So n equal to 24. So means that we pay 150 ringgit this annuity 24 times only. Okay, until 2 years only. So here n equal to 24 minus 1 divided by 0.007. S equal to Rm. So if you calculate this one, you will get 3905.24. Okay, this is not the answer. This is future value at the end of year 2. Now we want future value at the end of year 5. Okay, now at the end of 3 years, another 3 years, no more R. Okay, but the interest still compounded 8.4% every month. Okay, now this S becomes S1 here. This one becomes new principal in order to calculate future value at the end of year 5. But interest still compounded monthly 8.4%. Okay, so another 3 years here, you use formula compound interest. The interest still compounding, but no more annuity. So here you use formula S equal to P1 plus I power of N. Okay, because no more annuity. So here I put future value at the end of year 5. So S equal to P1 plus I power of N. So now our principal is 3905.24. 1 plus I 0.07. Okay, and how about N? So another 3 years, right? So N equals to M times T, which is 36. So if you calculate this one, you will get 44,613 ringgit 24 cents. Okay, so this is example where first 2 years you have annuity and the rest of the period no more annuity. Okay, so if there is no more annuity, then you use formula compound interest because here the interest still compounding but no more value R. Okay, so if you have R here, then you use formula annuity. With R here, you have value R. Okay, so I hope you can understand this example. Okay, now let's move to this example number 4. Nisha invested 100 ringgit every 3 months. Okay, every 3 months. So this one to refer the annuity. After 5 years in an investment scheme, she was offered 4% compounded quarterly for the first 2 years. So first 2 years compounded monthly 4%. Compounded quarterly. So look at here, if quarterly, the interest period is 3 months. Okay, so if compounded quarterly, then the annuity must be every 3 months. And 8% compounded quarterly for the rest of the period. For the rest of the period means that another 3 years. Okay, so total 5 years. First 2 years, 4% compounded quarterly. So balance another 3 years. Okay, interest period is still the same, but now interest rate is changed. Okay, find the accumulated amount at the end of 5 years, means that value S, and the amount of interest earned. Okay, here also to ease you to understand the question, you extract the info into timeline. Okay, extract the info into timeline like this. Okay, total investment period is 5 years. First 2 years, so let's say here T equal to 2. So first 2 years, interest rate compounded quarterly 4%. Compounded quarterly M equal to 4. Okay. Every 3 months, you wait 3 months and then calculate interest. And then so within 1 year, we have 4 times of frequency of conversion equal to 4 times. Okay, next. The rest of the period means that another 3 years here. So here another 3 years. Now K is changed, which is 8%, but still compounded quarterly. Okay. So in this question, it does not mention whether after 2 years there is no more deposit or no more annuity. So meaning to say that the annuity of 100 ringgit that Nisha pays every 3 months is for 5 years, along 5 years. So from beginning till the end of year 5, Nisha put or pays 100 ringgit every 3 months. Okay, previous example, after 2 years, no more deposit or no more annuity. But in this example, from beginning to the end, there is an annuity. Okay, how to calculate future value? Okay, since we have two different rates here, so we need to calculate future value at the end of year 2 first. Okay, why? Because after year 2, the rate is changed. Okay, so if the rate is still the same, you can directly calculate future value until at the end of year 5. Since after year 2, rate is changed, then we need to calculate value at the end of year 2 first. Future value at the end of year 2. Let's say I put it as S1. So what is S1? Future value at the end of year 2. Why we calculate this one? Because there are two different rates. So now with the annuity, right, along 5 years, there is an annuity. So we use formula annuity. S equal to R1 plus I power of n minus 1 divided by I. Okay, calculate value I and value n first. So here I equal to 0.04 divided by 4, which is 0.01. How about n for first 2 years? So every year we calculate 4 times. So if 2 years will be 4 times 2 equal to 8. So here S equal to 150 ringgit times 1 plus 0.01 power of 8 minus 1 divided by 0.01. So if we calculate this one, future value at the end of year 2, we will get 1,242 ringgit 85 cents. Okay, so here we have 1242.85. Okay, now we want to know value at the end of year 5. S1 now stop at year 2. So what happen if you wait or if you keep this amount for another 3 years? Okay, interest still compounded quarterly for 8%. Okay, so if this amount is 1, you keep it for another 3 years. What is the accumulated amount at the end of year 5? Okay, let's say I put it as S2. Okay, now the interest still compounding. Okay, so another 3 years, here this value, you use formula compound interest. Okay, because the interest still compounding here. So here 1242.85 becomes the principal. Okay, so now calculate S2. So what is S2? Future value of S1 at the end of year 5. So here we use formula compound interest. Why? Because the interest still compounding here. So now 1242 become the principal. Okay, how about I here? So another 3 years, now rate is different. Okay, calculate I here. Let's say I calculate here. I equals to K over M. 0.08 divided by 4 will be 0.02. Okay, how about N? Another 3 years. 1 year, we calculate 4 times interest. For if 3 years times 3. So another 12 times. So here 1 plus I is 0.02 power of 12. Okay, because now we are calculating another 3 years here at the end of 3 years. So if we calculate here, we will get RM1576.23. Okay, this one value at the end of year 5. So here you have 1576.23. Okay, this is not the final answer yet. Okay, why? Okay, look at 100 ringgit just now, annuity. Okay, so this annuity just now, we calculate this 150. We just calculate until year 2, right? But this annuity 100 ringgit is along the 5 years period. So we need to calculate this annuity for another 3 years. Okay, from here until at the end of year 2 until year 5. It means with annuity. Okay, let's say I put it as S3. So what is S3? Future value of annuity at the end of year 5. So use formula annuity S equal to R 100 ringgit. Sorry, this one mistake, not 150, 100 ringgit. Let me do correction first. So this value also wrong. So this is not 1242. So this one also wrong. So make sure you check one by one, okay? Okay, let me calculate this part first. So here 100 ringgit. So if we calculate this one, we will get 828.57. So here 828.57. So this one will be new principal for future value at the end of year 5. Okay, so here will be 828.51. Sorry, 57. So this amount, if we wait another 3 years, so here will be the new principal, 828.57. So let's check interest here, 2%, 12. Okay, so here S2 will be 10,141.696 will be 0.7. Okay, this is amount at the end of year 5. Okay, now annuity just now is along 5 years, right? But just now we just calculate at the end of year 2. So we have another 3 years. Annuity another 3 years here. We need to calculate separately, okay? Because just now rate is different. Okay, now we want to calculate annuity for another 3 years here. Okay, so use formula annuity. So 100 multiplied by, so another 3 years. So 1 plus I will be 0.02 power of n, so n will be 12, okay, because another 3 years here. Minus 1 divided by I, which is 0.02. So if we calculate this one, we will get 1341.21. Okay, this one value at the end of year 5. So if you look at here, so we have S3, this one is S3, okay? So what is S3? Annuity of 100 ringgit for another 3 years. So S3 1341.21. S2 just now 10141.70. Sorry, a bit messy here. Okay, if you look at this timeline, okay, we want to know value at the end of year 5, right? Okay, look at the end of year 5, how much we have here. So we have S2 and S3. Okay, so at the end of year 5, you total out these two values. Okay, S2 plus S3. So our answer at the end of year 5 S equal to S2 plus S3. So S2 just now 10141.70 plus S3 1341.21. So this one we will get 11,482 ringgit 91 cents. So how about the interest? Since we based on future value, R equal to S minus NR. As just now, 11,482 ringgit 91 cents minus N. Okay, NR. Be careful with the N. NR means that how many times we pay the annuity. Okay, so based on this question, annuity of 100 ringgit, you pay along 5 years. Okay, so it means that how many times you pay 100 ringgit? So first 2 years, 4 times. First 2 years is 8 times. Another 3 years, another 12 times. So 8 plus 12 equal to 20. Okay, so you pay 100 ringgit 20 times. Or what you can do, since it is compounded quarterly for 5 years, so n equal to m times t. M equal to 4, t equal to 5. So 5 times 4 equal to 20 as well. Okay, so 8 plus 12 also equal to 20. So how many times we pay for the annuity? 20 times. So what is the annuity? 100 ringgit. So here interest, if you calculate this one, you will get 9,482 ringgit 91 cents. Okay. Okay, for this question, doesn't matter if you want to calculate S3 first or S2 first, no problem. Okay, as long as you calculate all the values or all the annuity until at the end of year 5. And here, maybe some of you confused, why I use formula compound interest, not formula annuity, because up to here at the end of year 2, the interest still compounding, right? We keep this amount until at the end of year 5, another 3 years. Okay, why we did not use formula annuity? Because later on we will calculate annuity for another 3 years using formula annuity here. So if you see from beginning to till the end, you already calculate the annuity for 5 years. So this is S1 just now. Okay, now let's look at present value of ordinary annuity. Okay, the present value or the discounted value of an annuity is the sum of all present values of the individual periodic payments. Okay, present value must be at the beginning period of an annuity. Okay, so again, this one similar concept to previous topic, simple interest and promissory note, and also compound interest. So present value must be at the beginning of period. Okay. Present value of annuity is given by A equal to R multiplied by 1 minus 1 plus I power of negative n. So be careful here, power of negative n. Okay, so don't forget negative here, divided by I. Okay, previously, topic simple interest, promissory note, and compound interest, present value, we use symbol P, right? Okay, here in annuity, to differentiate with that topics, we use symbol capital A here. Okay, but the concept still the same. Present value must be at the beginning of the period. Okay, means that if you draw a timeline, here must be present value. Okay, or value A. A is present value for topic annuity. And value at the end of certain period here will be future value or accumulated value. Okay, if you look at here, formula S, future value, and present value A for topic annuity is almost similar. Okay, the difference is only at this part. Okay, at this part. 1 minus and power of negative n. Okay, formula S equal to R, which is the periodic payment, multiplied by 1 plus I power of n. So here 1 minus 1 plus I power of negative n. So here 1 plus I power of n, then minus by 1. Okay, so be careful. Check your formula correctly when you want to answer the question. Okay, because common mistake that student made is in this part. For present value, power is power of negative n. If S, power of n here. So be careful with these two parts. Okay. Okay, as usual, R is periodic payments. How much that you pay every month or every quarter or yearly. I is interest period. I is interest rate for each interest period. And N is the term of investment or number of interest periods. So calculation of I and N still the same. I equal to K over M and N equals to M times T. Now look at interest if based on present value. Okay, so in previous topic, simple interest and compound interest, how we can calculate interest? I equal to S minus P. But in topic annuity, how to calculate interest depends on what information that you have. Okay, for example, if you have info about future value, the interest is given by I equal to S minus NR. But if we have info about present value, so the interest is given by NR minus A. Okay, so be careful with formula interest for topic annuity. So NR is how many times we make payment for the periodic payments, okay, minus the present value. Then you will get the amount of interest. So again, when you calculate amount of interest, the answer cannot be negative. Okay, now let's look at some examples. Look at exercise 19 here, number 1. Find the present value, which is value A, of annuity of 500 ringgit every 6 months. Every 6 months. So every 6 months to refer topic annuity. Okay, so this is value R. For 10.5 years, if money is worth 7% compounded semi-annually. So if you make payment every 6 months, the interest must be compounded semi-annually. That is meant by ordinary annuity certain. Okay, so you cannot pay or you cannot make payment every 6 months, but the interest compounded quarterly. That one is not ordinary annuity certain. So if you make payment every 6 months, the interest must be compounded semi-annually. Or if you make payment every 3 months, then the interest must be compounded quarterly. Or if you make payment every month, the interest must be compounded monthly. Okay, so that is ordinary annuity certain. Okay, now let's check the info given. So 500 ringgit is annuity, which is value R. T 10.5 years, 10.5. K annual nominal rate 7%. Frequency of conversion, since interest period is 6 months, so 1 year we calculate interest 2 times. Okay, 12 months divided by 6 months, then we get 2. Okay, so in 1 year we calculate interest or you make the payment 2 times in a year. Okay, as usual, calculate interest rate for each interest period. So if 1 year 7%, every 6 months here, how many percent? So I equal to K over M, 0.07 divided by 2. So here equal to 0.035. Okay, and 1 year we calculate or you make payment 2 times. So if you make payment for 10.5 years, so N how many times? N equal to M times T, 10.5. So 2 times 10.5 is 21. Okay, find the present value. So present value, value A equal to R multiplied by 1 minus 1 plus I, power of negative n. So be careful with this formula. Don't confuse with formula future value, divided by I. Okay, substitute the value. R 500 ringgit multiply 1 minus 1 plus 0.035 power of negative 21 divided by 0.035. So if we calculate this one, we will get, okay, calculate in this part first. Okay, so 1 plus 0.035, we can directly press 1.035 power of negative 21. So press here negative 21. So this is this part. Okay, then 1 minus despite, which is refer to answer in your calculator now. So just press 1 minus answer equal. So this is numerator. So I show one by one because some of you do not know how to calculate or how to press calculator directly. Okay, divided by denominator, divided by 0.035. Okay, this is value inside square bracket. Okay, then multiply by 500. So present value equal to 7348.99. Okay. Okay, if let's say question asks you to find interest, so now we have present value. If interest based on present value equal to NR minus A. So N is 21 times 500 minus 7348.99. So remember, interest cannot be negative. Okay. So 21 multiplied by 500 minus 7348.99. So 3151.01. Okay, that is present value of annuity. Okay, now let's look at number 2. Jaswina deposits Y at the end of each month. So this is keyword to indicate topic annuity. Into an annuity that pays 4% compounded monthly. Okay, and moreover, in this question already stated annuity here. Okay, so use formula annuity. Don't use formula compound interest. Means that you use the correct formula. Okay, that pays 4% compounded monthly. So if you pay every month, the interest also must be compounded monthly. At the end of 5 years, the annuity is worth 13,259 ringgit 80 cents. At the end of 5 years, the value worth 13 ringgit 259 ringgit 80 cents. So value at the end of certain period is value S, okay, or future value. Find the value of Y. Now look at what is value Y. So if you look at here, RMY ringgit at the end of each month. So keyword here, each month. Okay, so this is to represent annuity, which is value R. So we know that here in this question, Y is the periodic payment. Every month, how much you pay Y ringgit. Okay, so Y referring to value R. Okay, let's check the info given. Annual nominal rate 4%, 0.04. Compounded monthly. So if you pay every month, then the interest also must be compounded monthly. So M equal to 12. At the end of 5 years, so T equal to 5. So value at the end of 5 years is value S. Okay, now we want to find the periodic payment R. Okay, which formula we need to use? Okay, we have two formula previously, which are either formula S and formula A. Okay, in both formula we have R in it. So which formula we need to use? Okay, look at the info given. So in this question, we have info about future value. Okay, so in order to find Y here or value R, so we use formula S. Okay, because the info given is about future value. So S equal to R multiplied by 1 plus I power of n minus 1 divided by I. So for topic annuity, you need to know to determine the values given. Okay, either it is a future value or present value. Okay, means that based on the keyword given. Okay, example. Okay, here I have certain keywords for future value and present value. So for example, simple amount, accumulated amount, future value, maturity value, amount at the end of certain period, means that this keyword to represent value S. Okay, and keyword for P, present value, For example, initial saving, face value, deposit amount of RM, how many ringgit? So deposit referring to value principal. Loan of RM, how many ringgit? Loan referring to present value or principal. He borrows, invest, okay, also represent principal value or present value. Okay, so based on that question, you need to understand what are the values given. Then you can choose the correct formula. Okay, now let's calculate value I and value N. So I equal to K over M, 0.04 divided by 12. So again, this is in standard form, okay? Multiply by 10 power of negative 3. So change to its actual number. So you press shift ENG, again shift ENG, okay, until you get multiply by 10 power of 0. So here to indicate its actual value. So I 0.04 divided by 12. 0.0033, round off to 4 decimal point only. Okay, N equal to M times T. 12 times 5, which is equal to 60. Okay, substitute the values. Okay, we know that S is 13259.80 equal to R multiplied by 1 plus 0.0033 power of 60 minus 1 divided by 0.0033. Okay, calculate value in this square bracket first. Those who want to use fraction, value I also no problem, but later on your answer will be slightly different. Okay, for example, 0.04 divided by 12. Okay, if in fraction is, sorry, this is 4 over 12. 0.04 over 12. Okay, if value I, you want to use fraction, here 1 over 300 also no problem, okay? So, but if you use fraction, later on your final answer will be slightly different from what I will show here, okay? Because if you use fraction, it will use all decimal points here, okay? No problem, as long as your method and your calculation and substitution is correct. Okay, now let's calculate this part value inside square bracket here. So 1 plus 0.0033 will be 1.0033 power of 60 equal minus 1 and then divided by I. 0033. So inside bracket is 66.2318. So R equal to 13259.8 divided by 66.2318. So the monthly payment here, because we pay every month in this question. So 13259.8 divided by 66.2318. 200 ringgit 20 cents. So those who are using fraction for value I, maybe you will get exactly 200 or less than 200. Okay, depends. So this one due to decimal point. So no problem. If you use fraction also, no problem. Okay, now let's look at number 3. Zaim bought a low-cost terraced house for 35,000. He paid a 10% down payment and the balance was borrowed from bank, balance borrowed from bank that charge interest at the rate of 8.5% compounded monthly. Okay, this loan will be repaid in monthly installment for 10 years. Okay, so if the interest is compounded monthly, then the payment also must be on monthly basis. Okay, find the monthly payment. Monthly payment means value R. and the total interest earned. Please do some correction in this part since this is about borrow money from banks. So if we borrow money from bank, we don't say that the interest is earned. Okay, if we borrow from bank means that we need to pay the interest, and the total interest he need to pay. Okay, then correct. Okay, because we borrow money from bank. If we invest, then the interest will be earned. Extract the info given first. Okay, we extract from this part first. So 8.5% is annual nominal rate. Okay, 0.085. Compounded monthly. So M equal to 12. Term 10 years. Okay, then we want to find value R. Okay, now which formula? Formula A present value or value S. Okay, both formulas we have R in it. So which one to use? A or S? Okay, now look at what are the info given. Okay, the cost of the house is 35,000. Okay, and then down payment made is 10%. Okay, what is the amount of down payment? DP is down payment. So 10%, 0.1 from 35,000 will be equivalent to 3,500. Okay, now we want to buy this house, cost 35,000. Okay, deposit or down payment is 10%. So 10% also equivalent to 3,500. So this one already paid. Okay, what is the balance cost of the house? So balance will be original cost, which is 35,000 minus down payment that you already paid, which is 3,500. So you have another 31,500. So in order to buy the house, where to get this 31,500? Okay, so from the question, it says that the balance was borrowed from the bank. Okay, so borrow from bank. So if borrow from bank, means that this one you make a loan. Okay, so when we make a loan, 31,500 is actually value, present value. Okay, so that's how you find either the info given is present value or future value. You need to understand from the question. So since we have present value, value A, so use formula A. So A equal to R multiplied by 1 minus 1 plus I power of negative n divided by I. So be careful with formula. Make sure you write the correct formula. Okay, now let's calculate the interest rate per interest period, which is value I, 0.085 divided by 12. So 0.85 divided by 12. So change in its actual value. So 0.0071. If you want to use fraction also, no problem. So n equals to m times t. 12 times 10 equal to 120. So A 31,500 equal to R multiply 1 minus 1 plus 0.0071 power of negative 120 divided by 0.0071. Okay, calculate value inside square bracket. We will get 80.5849. So R equal to 31,500 divided by 80.5849. So here every month you need to pay 390 ringgit 89 cents. Okay, then interest that he need to pay I equal to and R minus A, because now we are based on present value. So N120 times R 390 ringgit 89 cents minus A 31,500. So the interest is RM 15,406 ringgit 80 cents. Okay, now let's look at number 4. Howard took a loan worth 30,000 at 2.5% compounded monthly and had to make monthly payments for 3 years. Okay, so again, if the interest is compounded monthly, then the payment also must be in monthly basis. Okay, calculate the monthly payment and the total interest. Okay, monthly payment means that value R. Okay, here which formula we need to use, whether present value A or future value S. As I said before, you need to understand what are the info given from the question. Okay, so if you look at here, Howard took a loan. Okay, the keyword here is loan. So loan to refer present value, which is value A. So 30,000 is value A. Okay, now extract the info given. Annual nominal rate 2.5%, compounded monthly, so M equal to 12. For how long? For 3 years, so T equal to 3. Okay, calculate the monthly payment, which is value R, and the total interest I. Okay, as usual, calculate the interest rate for each interest period. So here, 1 year, the rate is 2.5%. Interest compounded monthly. So every month, how many percent? So 0.025 divided by 12. So this one is 0.025 divided by 12. Zero point zero zero two one. Okay, so if you want to use fraction also no problem. 0.0021. Okay, then calculate n. N equals to m times t. N 12 times 3 years equal to 36. Okay, now we have info about present value, so use formula present value. So present value here, power of negative n. So be careful with formulas. Make sure you write and copy the correct formulas. Okay, then substitute the values. A 30,000. Now we want to find R. Multiply 1 minus 1 plus 0.0021 power of negative 36 divided by I. 0.0021. Okay, calculate value inside square bracket. So here we will get, so do this part first, 1.0021 power of negative 36. Okay, then 1 minus this one, so just press 1 minus answer, and then divided by 0.0021. So this is value inside square bracket, so 34.6379. 34.6379. 6379. So R equal to 30,000 divided by 34.6379. So R is 866.10. Okay, interest. So since we have present value, so use interest based on present value, and R minus A. And 36, R is 866.10 minus A is 30,000. So remember, when you calculate interest, interest cannot be negative. So 36 multiply 866.10 minus A, 30,000. 1179.6. Okay. So in order to do this question, you need to understand what are the info given from the question. Okay, so use the correct formula. Okay, now let's look at number 5. Noni wants to have 2,863 ringgit 35 cents at the end of certain period of time. At the end of certain period of time. Okay, so the keyword here is at the end of certain period of time. At the end. So this is actually value S, okay, or future value. So that is the part where you need to understand what are the info given from the question. Okay, her plan is to deposit 100 ringgit at the end of each quarter. At the end of each quarter. So means that 100 ringgit is value R. Okay, the annuity. Each quarter means that every 3 months. Okay, into a fund that pays 6% compounded quarterly. So if you pay every quarter, the interest also must be compounded quarterly. Compounded quarterly also equivalent to compounded every 3 months. Okay, how many quarterly payments Noni made in order to save 2,863 ringgit 35 cents? How many quarterly payments must Noni make in order to save 2,863 ringgit 35 cents? So how many quarterly payments referring to value N? Okay, we want to find value N. How many quarterly payments? Okay, now extract the info given. So we know that future value S equal to 2863.35. 100 ringgit is value R equal to 100. Annual nominal rate 6%. Compounded quarterly M equal to 4. Okay, how many quarterly payments? So means that we want to find value N. Okay, as usual, calculate the interest rate per interest period, which is value I. So I equal to K over M. K just now 6%. M divided by 4. So 6% over 4 is 0.015. Since we have info about S, so start with formula S. So S equal to R 1 plus I power of N minus 1 divided by I. So since we want to find value N, no need to substitute N equals to M times T, okay, because we want to find value N. If question asks us how long the payment or how long was the investment period, then you put N equal to M times T because we want to find value T. So in this case, you just let N equal to M. Okay, now substitute the values as to 863.35 equal to 100 multiply 1 plus 0.015 power of N. So now we want to find value N minus 1 divided by 0.015. Okay, how to find N? Okay, you can bring this R 100 ringgit to left hand side first. So 2863.35. So multiply, go to left hand side, divided by 100 here. So on right hand side, what we have is, okay, you can solve in this bracket. So here we can write 1.015 power of n minus 1 divided by 0.015. Okay, settle this part first. 2863.35 divided by 100, 28.6335. Okay, then what you can do, bring this one, denominator to left hand side. So divide to left hand side, multiply by 2863.35. Okay, then you move this one. Minus 1 to left hand side become plus 1. So what you have on right hand side is 1.015 power of n. Okay, solve value on left hand side. 28.6335 multiplied by 0.015 plus 1. So we get 1.429525. So I continue here. 1.4295025. We check 1.4295025. Okay, so on right hand side we have 1.015 power of n. Okay, now n in terms of power. So in order to eliminate power of unknown values here, so what we can do, we can apply log. Okay, so if right hand side you put log, left hand side also you need to put log. So log 1.4295025. Okay, n you bring in front. So here becomes n multiply, dot means multiply. And then put log 1.015. So n equal to log 1.4295025 divided by log 1.015. So remember, n, how many quarterly payment? N cannot be negative. Okay, log 1.4295025 divided by log 1.015. So equal to 23.999. So n equal to 23.999. So since how many quarterly payments, round off to nearest whole number. So n equal to 24. So annuity of 100 ringgit, you pay for 24 times. Okay. Let's say question asks you to find how long was the investment period, means that how many years. What you can do in order to find t, you substitute value n equal to 24. Okay, example, if question asks you how many years, n equal to m times t. So we know that n equal to 24, conversion period just now equal to 4. So 4t. So t equal to 24 divided by 4, which is 6 years. Okay, that one if question asks you to find the period of investment. So in this case, it asks you to find the n, okay, or how many quarterly payments. Okay, now let's look at number 6. Ilham borrowed 100,000 at 12% compounded monthly. How many monthly payments of 2,000 ringgit should Ilham make? Okay, again, how many monthly payments means that we want to find value n. Okay, so R is 2,000 ringgit monthly payment. So means that 2,000 ringgit is the periodic payment, which is based on monthly basis. So if we pay by monthly basis, the interest also must be compounded monthly. Okay, now we want to know what is 100,000. Okay, as I said before, look at the keyword here. 100,000, borrow represent present value A. Okay, so now let's extract the info given. A is 100,000. Annual nominal rate 12%, 0.12. Compounded monthly. And R monthly payment or the periodic payment 2,000 ringgit. Okay, as usual, calculate interest rate per interest period, which is value I. So 0.12 divided by 12 is 0.01. Okay, N equal to N. Okay, because now we want to find how many monthly payments. Means that referring to value N. Okay, which formula we need to use? So again, both formula A and formula S, we have R in it, right? So now we have info about A, present value. So we start with formula present value. So A equal to R, 1 minus 1 plus I, power of negative N, divided by I. So A equal to 100,000. Monthly payment 2,000 ringgit times 1 minus 1 plus 0.01 power of negative N. Okay, we want to find value N here. Divided by 0.01. So again, the same procedure as from previous question. Okay, you can move value R here to left hand side. So 100,000 divided by 2,000. So on right hand side, 1 minus 1.01 power of negative N divided by 0.01. Okay, 100,000 over 2,000 is 50. Okay, bring denominator here to left hand side. So divide, so here multiply. Okay, this positive one bring to left hand side. So positive to left hand side minus. So right hand side we have negative 1.01 power of negative N. Okay, now solve value on left hand side. So I continue on right hand side here. Okay, 50 times 0.01 minus 1, we will get negative 0.5 equal to negative 1.01 power of negative N. So negative, we can cancel here. Okay, now N is in terms of power. So how to find value N or eliminate power of unknown? So we can apply log. So left hand side you put log 0.5. So power of unknown you bring in front. So negative N multiply, dot means multiply, log 1.01. So N equal to, sorry, not N, negative N. So be careful with N here, negative sign here. So negative N equal to log 0.5 divided by log 1.01. Negative N equal to log 0.5 divided by log 1.01. So we get negative 69.66. Okay, so round off to nearest whole number. Since N, how many monthly payment? How many? So it should be discrete. Okay. So here we get negative 69. What is now? Negative 69.66. Okay, round off to nearest whole number, negative 70. So this is negative N. We want N only. So negative later on become positive. So N equal to 70. Logically, value N cannot be negative because how many monthly payments? So you cannot say Okay, I pay negative 70 times. Okay, so very illogical. So make sure n is positive, cannot be negative. So in this case, Ilham makes 70 payments of 2,000 ringgit every month. Okay, let's say in this question, it asks you to find the term of borrowing period. How long Ilham pay 400,000 ringgit? How long means that referring to value T. How many years? Again, if you want to find T, substitute into N. So we know that N equals to M times T. N 70, M 12 times T. So T equal to 70 divided by 12. So how many years? 70 over 12 is 5.83 years. Okay, 5 years something. 5.83 years. Okay, the one if question asks you to find how long, okay, or the term of borrowing period. But in this case, it only asks you to find the number of monthly payments, which is value N. Okay, now let's look at last part under topic annuity, which is outstanding loan and outstanding areas. Okay, now look at what is outstanding loan and outstanding areas. Okay, first let's look at outstanding loan. So outstanding loan is the case where we want to settle all the loan or all the amount of debt or balance earlier. Okay, you want to settle earlier before its maturity date, for example. Okay, before the time arrives. For example, if you make a loan for 10 years, but before 10 years, you want to settle it earlier. Okay, so that is meant by outstanding loan. Okay, however, outstanding areas. So outstanding areas is the case whereby we want to pay amount of unpaid payments. Okay, example. Okay, let's say I give example. You make a loan for 1 year by monthly basis. Means that every month you pay, for example, 100 ringgit. Okay, just example. Every month our monthly payment 100 ringgit. 1 year monthly until 12 months. Okay, so let's say first month you pay 100 ringgit, second month you pay 100 ringgit, but suddenly on third month here you don't have enough money. Okay, so here will be the first areas you did not pay the annuity. Fourth month also you don't have enough money, so then you did not pay the annuity of 100 ringgit. Okay, then here fourth month, fifth month, sixth month, and so forth. Okay, let's say there are 2 months that you cannot pay the annuity as usual. Okay, on fifth month here, how much you need to pay to cover the 2 months areas just now. Okay, meaning to say that on fifth month here you need to pay the third payment, the fourth payment, as well as the fifth payment. Okay, so on fifth month here you need to pay for 3 months payment. So how much you need to pay? Okay, so that is concept of outstanding areas. You want to pay amount of unpaid payment at certain period of time. But outstanding loan here, you want to settle your debt earlier. Okay, example, I give the same example. Monthly payment for 1 year. Okay, let's say here 11, 10. Okay, first month you pay 100, second month you pay 100, third month you pay 100. Okay, up to 10th month. Okay, here you want to settle all. To settle all earlier, okay, before 1 year or before 12 months. That is outstanding loan. You want to settle your loan or your debt earlier before the time arrive. But outstanding areas, amount that you need to pay for the unpaid payment before. Okay, so that is meant by areas, or in bahasa areas is tunggakan. So if you have 2 months areas here, third month here, how much you need to pay? Okay, now let's look at example. Okay, now let's look at this example on how to calculate the outstanding loan and outstanding areas. Okay, Diana borrowed 80,000 at 12% compounded monthly for 3 years. Okay, first extract the info given. Okay, Diana borrowed. So this is the keyword. Borrow means that 80,000 is present value. So extract the info given. A 30,000 present value. 12% compounded monthly. So K equal to 12%, M equal to 12. Okay, for 3 years. So if compounded monthly, then the predict payment must be paid by monthly payment. Okay, A find his monthly payment, which is value R. So if compounded monthly, again, the payment also must be paid by monthly basis. Okay, as usual, calculate value I. So I equal to K over M. 0.12 divided by 12 equal to 0.01. And N equals to M times T. 12 times 3 equal to 36. Okay, so how to find R? So which formula? So since we have info about A, then we use formula A. So A equivalent to R multiplied by 1 minus 1 plus I power of negative N. So be careful, if A power of negative N divided by I. Okay, substitute the values. So A is 80,000. So we want to find R here. Multiply 1 minus 1 plus I. So I just now 0.01. N here equal to 36. So power of negative 36 divided by 0.01. Okay, now calculate value inside this square bracket. So if you calculate this one, you will get 30.1075. So R equal to 80,000 divided by 30.1075. So monthly payment is RM 2657.15. Okay, so every month you pay this amount. Okay, now let's look at question B. If he had not paid her first 5 monthly payments, how much should he pay on her 6th payment to settle all outstanding arrears? So remember, arrears is we want to pay amount of unpaid payments before. Okay, so arrears or in bahasa is tunggakan. Okay, so at certain period of time you want to settle these arrears. Okay, first, which formula we should use? Present value or future value? Okay, so the concept like this. Okay, I give example, monthly payment for 1 year. Okay, 1, 2, 3, 4, 5, and so forth until 12 year. Okay, areas. Okay, let's say first month you make payment, second month you make payment. Third month you don't have money, fourth month you don't have money, and let's say on the fifth month you have enough money. So on the fifth month here you decide to settle or you want to pay these 2 months area. Okay, so on the fifth month how much you should pay? Okay, meaning to say that on fifth month you need to pay for 3 monthly payments. Means that for the third month, for the fourth month, and the fifth month. So altogether 3 payments. Okay. So which formula, A or S, present value or future value? So the concept is like this. Okay, amount that we should pay now or you should pay earlier here. So since you don't have enough money, then you decide to settle it in future. Okay, so payment, third payment, fourth payment that you should pay earlier, but now you pay on the fifth payment. So value that you pay in future, so we use concept future value. Okay, so areas, remember areas, you must use future value. So areas use future value. Means that if question asks you to calculate outstanding areas, use formula S. So to ease you to remember areas as S. Okay, so outstanding areas use formula S, future value. Okay, look at what is formula S. S equal to R multiplied by 1 plus I power of n minus 1 divided by I. Okay, substitute the values. So S here, so S is amount that you need to pay on the 5th month here. Okay, so means that on the 5th month, you want to settle for 3 monthly payments. So how much you should pay on the 5th month? Okay, S equal to R. So just now R equal to, from question A, just now R is to 657.15 multiplied by 1 plus I, which is 0.01 power of n. Okay, now look at value n. Okay, please remember that n here is not equivalent to total number of payments, which is 36 just now. Okay, so n not equal to 36. Okay, in this case, okay, look at the question. Another one thing is, if outstanding areas, the keyword here, for example here, if we had not paid her first 5 monthly payment, not paid means that areas. Another keyword for areas is, if he fails to make payment, so means that is areas. Okay. So if he has not paid her first 5 monthly payments, how much should he pay on her 6th payment? So this question said that the first 5 monthly payments is unpaid. So on the 6th month, how much he should pay? So means that on the 6th month, he should pay for 6 payments. Okay, this example I give. First and second month, you already make payment, but third and fourth month, you did not make any payment. But on the 5th month, you want to settle these 2 months areas. So meaning to say that on the 5th month here, you need to pay for 3 payments. So based on this question, first 5 monthly payments is unpaid. So on the 6th month, how many payments you actually make? Okay, so means that 6 number of payments. So in this case, number of unpaid payments. So I put, for example, here, question B, unpaid payment equal to 6. Okay, number of unpaid payment. N equal to 6. Okay, so remember, N here for question B is not equal to 36. Means that you want to make payment for how many months? So here N equal to 6 minus 1 divided by I. So if you calculate this one, you will get 16,346 ringgit 83 cents. Okay. Okay, now look at every month just now we pay to 657.15. Okay. Okay, let's say every month we pay this amount to 657.15. Okay, now number of payment equal to 6 multiplied by 6. Okay, if you follow the schedule, means that you pay every month by this amount, you actually pay 15,942.9. But since there are 2 months areas just now, 5 months areas just now, you pay a bit more, which is 16,346 ringgit 83 cents. This is amount if you follow the schedule. So this is amount if there are 5 months areas. So if there are areas or outstanding areas case, you pay a bit more as what you should pay. Okay, so why more? This is because, for example, this one we can say like a penalty. Okay, because case of outstanding areas. Okay, so if you follow the schedule, 6 months, every month you pay this amount, multiply by 6, we actually pay about 15,942 ringgit 90 cents. But because of there are areas, you pay a bit more. Okay, it's just uh, like a penalty. I already explained why n equal to 6 here. So just now, unpaid payment is 5 months, right? Not paid her first 5 monthly payments. Okay. 1, 2, 3, 4, 5, 6, and so forth. Okay, first month unpaid, second month unpaid, third month unpaid, fourth month unpaid, fifth month also unpaid based on this question. Okay. But on 6 months here, you decide to settle the areas. Okay, you want to make payment on the 6 months. So on the 6 month, how many number of payments you actually want to make? Okay, so areas 5 months. Areas here 5 months unpaid. So on 6 months, you want to pay as well. Okay, so means that 5 plus 1, so equal to 6. So that's why here n equal to 6. Okay, now let's look at example of outstanding loan. Okay, so outstanding loan is we want to settle all the loan earlier before the time. Okay, look at question C here. If we had wanted to settle the entire loan immediately after paying the first 5 monthly payments, how much additional payment did we have to make? Okay, so which formula we want to use? Again, whether use formula present value or future value. Okay, look at the concept here. So number of payment just now is 36, right? Compounded monthly for 3 years from original question. So T equal to, N equal to 36. Okay. Okay, in total, we need to make 36 monthly payments. Okay, now this case is outstanding loan where we want to settle the loan immediately before the 36 months. Okay, let's say I draw a line here. 1, 2, 3, 4, 5, 6, and so forth until 36 months. Okay, so this is the last month that you should make the payment. Okay, from this question, it says that you already paid for first 5 monthly payments. So 1, 2, 3, 4, 5. So these 5 monthly payments already paid. Okay, how much additional payment did he have to make? So meaning to say that on the 6 months here, you want to settle all earlier. Okay, before 36 months, you want to settle it earlier. Where you want to settle it all on the 6 months. Okay, total number of payments that we want to make is 36. So on the 6 months here, how many number of payments we want to make actually? Okay, so n equal to, so original number of payment is 36. Okay, we already make payment for 5 months, right? We already paid for 5 months. So we have another, how many number of payments? 36 minus 5. So which is 31 number of payments. So on 6 months here, we want to pay for 31 payments. Okay. Okay, which formula? Present value or future value? So outstanding areas just now, we use future value. Value that you pay now. Okay, but since areas, you don't have enough money, it become areas, then you pay in future. When you pay in future, we says that we use future value. Okay, for case of outstanding loan, Okay, you want to settle it all earlier. For example, payment on the 7 month here, 8 month, 9 month, 10 month, and so forth, where you should pay it in future, but now we want to pay it earlier. We want to pay now. Okay, so if you want to pay now, now means that present value. Okay, so case of outstanding loan, we use present value, but outstanding area we use future value. Okay, n here in this case n equal to 31. So now on the 6th month you want to pay for 31 number of payments. How much you should pay? Okay, now we know that if outstanding loan, you use formula A. So A equal to R multiplied by 1 minus 1 plus I power of negative n divided by I. So A equal to, A is represent amount that you should pay on 6 months here. Okay, you want to settle all the debt earlier. Okay, R just now is 2657.15 multiply by 1 minus 1 plus I, so I is 0.01. Okay, N is number of payment that we want to make on the 6th month here, so which is N equal to 31. So power of negative 31 divided by I, 0.01. So if you calculate this one, you will get RM 70,526 ringgit and 83 cents. Okay, so this is the amount that you made on total amount that you should pay on the 6th month. Payment on the 6th month. Okay, a total payment on the 6th month. Okay, you settle it all on 6th month before month 36. So again, if you look at here, okay, R just now every month we pay 2657.15. Okay. Okay. If now we make payment for 31 months, okay, 2657.15, which is monthly payment here. Okay, multiply 31. Okay, you make payment for 31 payments here. So this one equal to what? 82371.65. Okay, but now you calculate A, present value, amount that you pay on 6 months here, 70,526 ringgit 83 cents, which is less than amount that you actually need to pay if you follow the schedule. Okay, so since you pay earlier, okay, you pay earlier, you settle the debt earlier, you pay a bit less than what you actually need to pay if you follow the schedule. If areas just now, okay, since areas, you need to pay a bit more from actual value that you need to pay. It is like a penalty. But in outstanding loan here, if you settle all your debt earlier, you pay a bit less. Okay, so this one is just like a reward because you pay earlier. Okay, a reward or maybe a bonus because of you pay earlier. So this is amount if you follow the schedule. Okay, so if you follow the schedule for another 31 months, this is total amount that you actually pay. If every month you pay by this amount. Okay, so that is outstanding loan and outstanding areas. So for outstanding loan and outstanding areas, be careful with value N. Okay, look at the number of payments that you actually want to make on that particular month. Okay, to sum up this topic, if case outstanding loan, we use present value. Okay, use formula A. If outstanding areas, we use formula future value S. Okay, so to ease you to remember, areas got S here, so then use formula S. Outstanding loan, use formula A.